Hello and welcome to a new devlog video for Peasant Uprise. So things are moving along quite nicely and I'm close to being done with the second level. But in this episode I want to share some approaches and decisions I've taken for the overall engineering architecture of the game. First item to cover is the tooling. While I could have chosen to build a custom game engine using OpenGL, unfortunately, I don't have the luxury to spend 3 to 5 years to create a custom game engine and build a first game. When shopping around for an engine, I had to look beyond Peasant Uprise. Mastering a game engine takes time, so I wanted to make sure it would also be a good fit for other ideas that I may undertake in the future. The main takeaways that led me to Unity is the .NET C# nature of the platform, the 2D capabilities of the engine, and overall it seems like the platform which is growing rapidly and in the right direction, tackling performance by default. That's not to say that Unreal Engine is unfit to do the job by any means. In fact, it has more maturity and it's better than Unity in many ways, but I had to look at it as a whole of capabilities it offers versus what I need and what I'm most comfortable with. Aside from the game engine itself, I tried to keep it as lean as possible, adding the least amount of extensions. Moving along the actual code structure, at the bottom of it all lies a serialized representation of my game data. These are plain classes that handle data that needs to persist between game loads. This is what is normally referred to as the application data model. But by far the pillars of logic are what I call managers. These are singleton mono behaviors that persist throughout the game and do not get destroyed between the scenes. Since they follow the singleton pattern, there is always one sole instance of these managers and they offer a static instance that can be easily accessed from any other code. These managers can talk to each other in a way that the peasant manager will grab data from the data manager, and the world manager may play a sound on a UI event by calling the audio manager. These managers are also designed to handle operations that affect multiple objects. Next in line are the controllers. I define controllers as the scripts that affect the main behavior of an object. These controllers' responsibility is to handle its own object and it alone. Aside from controllers which are more unique to an object, I also have identified the need of smaller modules, which for me are independent behaviors that can be shared among other objects. For example, a peasant controller and an enemy controller are different things. However, they both have one common need to be able to engage in combat. And hence, I've isolated the combat mechanics into a combat module that I can attach to both objects. However, the main rule I follow regarding these modules is that they should be pluggable. In other words, having a combat module or not should not cause any other module or the controller itself to break. This is especially useful when it comes to inheritance. All three peasants, enemies, and NPCs inherit from an actor controller. However, there is a mix and match of what each entity should really support. Both enemies and NPCs need a patrol AI element. However, peasants do not. In my case, peasants and enemies have health and energy modules. However, NPCs do not. So it's convenient to work on a modular plug-and-play manner so I can easily add behaviors as needed. At the end of the chain lies the physical object or view, which in this case rendered by the game engine. Looking at this pattern, one can easily distinguish a very common coding practice called model view controller, where the managers serve as a business layer in the hierarchy. Working on a project that demands quite a bit of logic really makes you dig deep in some complex coding practices. Peasant Uprise makes heavy use of inheritance, delegates, and scriptable objects to help isolate the source code and configuration. The camp mode also requires more particular AI work, which proved to be a tough one. I use a system of chain coroutines to handle camp work, from going to gather your tools, to wielding that tool and heading to a work point, a scriptable object, where a task needs to occur. This task will carry with it an animation, sound, maybe some requirements, and normally it has an outcome. After each session of work, the peasant will head back to the cart and will trigger a logic that will define what to do next, which could be resting a bit, eating a well-deserved lunch, relaxing, or going back to work. Obviously, each work that yields a resource will need to be accounted for and stored in the data model. So yeah, a lot of fun. With that said, please like and subscribe, and I'll see you on the next update.